We're going to talk about a fundamental law of physics that, honestly, is behind almost everything you experience, from how warm a fire feels to why your Wi-Fi signal drops. It's a simple rule that, once you get it, you'll start seeing it absolutely everywhere.
So, think about this for a sec. You're at a bonfire, right? You take a few steps closer, and wow, the heat is really intense. But then you take just a few steps back, and the warmth just vanishes. It fades away way faster than you'd think. What's going on there?
Well, that super fast drop-off, it's not just a feeling, and it's not a trick of the wind. It is a fundamental, predictable rule of the universe doing its thing. It's a precise mathematical principle that explains how all sorts of energy and forces spread out.
So let's start right there with this everyday mystery of why things seem to fade into nothingness as you move away from them.
And here's the thing, it isn't just about the heat from a fire. Nope, it's also the light coming from a lamp, the sound bumping from a speaker, the pull of gravity from a planet, even the signal from a radio tower. If it starts at one point and radiates outward, you can bet it's following this law.
So, why does this happen? To really get the main idea, let's forget the math for a minute and just use a simple analogy. It's all about building that gut feeling for how it works first. Okay, picture this. You've got a can of spray paint. You hold it just 1 foot from a wall, you press the button for 1 second, and boom, you get a nice, thick 1-foot square of paint. Easy enough? Now, don't change a thing, except step back so you're 2 feet away from the wall. You spray for that same 1 second. That same little puff of paint now has to travel twice the distance, so it spreads out way more. It now has to cover an area that's 2 feet tall and 2 feet wide. See that? It now has to cover 4 of those original squares.
And that is the absolute key. The amount of paint, or heat or light or sound is exactly the same. It didn't just disappear into thin air. It just got diluted. It spread super thin over a much, much bigger area. So at twice the distance, the intensity at any single spot is only 1/4 as strong as it was before.
All right, now that we have that spray paint visual locked in our heads, let's see how it connects to the really elegant formula that describes this whole thing perfectly.
The official name for all this is the inverse square law. That sounds a little complicated, but all it's saying is that the intensity of something is inversely proportional, which just means as one thing goes up, the other goes down, to the square of the distance from where it started.
And this is what it looks like in math terms. Intensity is proportional to 1 divided by the distance squared. That little 2 up there, that's everything. That's the secret sauce. It's not just that things get weaker with distance, they get weaker with the square of the distance. And that's why the effect feels so dramatic.
This graph just makes it so clear. Look at that drop-off. At 1 unit of distance, whatever that is, a foot, a meter, you've got 100% of the intensity. But just double the distance and bam, you're all the way down to 25%. Triple it, and you're at around 11%, which is 1/9 of the original strength. It falls off a cliff.
And this table, this is the real aha moment. Let's say you move 10 times farther away from something. Like you go from 1 meter to 10 meters away. You'd think the strength would be, what, 10%? Nope, it's 1%. 1 divided by 10 squared is 1/100. That is a huge loss of power.
So, okay, this isn't just some abstract formula for a physics class. This one simple rule explains so many things in our universe, from what's happening in your living room to what's going on in the deepest corners of space.
And that is not an exaggeration. It really is a rule that operates on a totally universal scale. Let's look at just a few examples.
First up, light. This law is the reason a star that might be thousands of times bigger and brighter than our own sun just looks like a tiny little dot of light in the sky. Its incredible energy has spread out over such an unimaginably vast distance that only a tiny fraction reaches our eyes.
It's the exact same deal for sound. If someone shouts at you from across a football field, you can barely hear them. But if they did that same shout right next to your ear, it'd be deafening. The sound energy just spreads out and gets weaker and weaker.
You know, even gravity, the force that literally holds the cosmos together, has to obey this law. The Earth's gravity is incredibly strong when you're on it, but it weakens with the square of the distance. That's why astronauts can be weightless just a few hundred miles up. They're far enough away that the pull has faded dramatically.
And let's bring it right back home, your Wi-Fi router. This law is the reason you lose your signal in the back room. The radio waves it sends out get exponentially weaker as they pass through walls and travel across your house, until finally they're just too diluted for your phone to even pick up.
So, what's the big takeaway here?
It's pretty simple. Energy and forces that come from a single point spread out in an ever-expanding sphere. As that sphere gets bigger, the energy on any part of its surface gets weaker. And that drop-off isn't gentle. It follows the square of the distance.
It's a beautifully simple and incredibly powerful rule. So the next time you walk away from a speaker, or lose cell service, or just look up at the night sky, you'll know exactly what's going on. You'll see that elegant law at work. So, now that you know the pattern, where are you going to spot it next?